In problem 17, we're going to rewrite the expression in exponential form. So my index isn't shown, so my index must be 2. My power isn't shown here, so it must be 1. My index is my denominator. My power is my numerator. So I got negative 17 to the 1/2 power. Number 18, I'm going to write as exponential form. My index is 3, so that's my denominator. My power is 8, so that's my numerator. So that's how I got y to the 8/3. In problem 19, I'm going to write this as a radical. My denominator is 7, so that's my index. My power is 3, so it's still my power. That's how I got the 7th root of n cubed. In problem 20, I'm going to write in radical form. I have y to the negative 4/3. So if I have a negative exponent, it means change locations. So that means I'm going to have 1 over y to the 4/3. Now it's positive. So I can't have a radical in the denominator. If I have 4/3, I want to get this 4/3 to be a whole number. So if I multiply it by 2/3, that would give me 6/3. So that's how I got 2 in the denominator. In my numerator, I have y to the 2/3 power. And since I'm going to write as a radical, my denominator is the index. My power numerator is 2. In problem 21, I'm going to simplify. I notice right away negative 27 can be factored to negative 3, negative 3, negative 3. And I'm going to use my rational exponent. So I have negative 3 to the 3rd power. And I take this, multiply it by 2/3. So when I take my 3, make it a fraction. And then I noticed the 3's reduce. So I have 2 over 1. That's how I got 9. Number 22, first thing I noticed, I could factor 16. So I have 2 times 8. And I factor 8, which is a perfect cube. That's how I got 2 to the 4th power. And I take 2 to the 4th power, multiply it by 3/4. I'm going to write 4 over 1 as a fraction. And I notice the 4's reduce when I multiply these together. So I get 2 to the 3rd power, which equals 8. You also can solve this by using radicals, but this is a simpler way. In problem number 23, I'm going to simplify the difference here. I notice right away I have like terms because they're both cube root of 2x. So I am just going to go 7 minus 3. That's how I got 4 cube root of 2x. In problem 24, I notice right away I can factor 32 and 72 before I see if I can find a sum here. So I'm going to factor 32, 8 and 4, and that's how I got all these 2s. So that's where all those 2's came from. Notice 2 is not under the radical, so it stays not under the radical. Then I factor 72, I get 9 and 8, I factor 9, and then I factor 8. That's where I got those. I also factor my x squared, so I got x and x. That x squared, x and x. I am looking for sets of 2's to come out. So I have a set of 2's here, a set of 2's here. That's how I got that 2 and that 2. This 2 stays outside the radical. I have a set of x's. That's where that x came from. So the next one I have a set of 3's and a set of 2's, and the x comes out. That's where this came from. So now I notice I have square root of 2 for both of them. So I'm going to go ahead and add. I have to use my absolute value rule here because I had an even index and I had an even power, but I got an odd answer for my x. That's why I need an absolute value. In problem 727, I'm going to go ahead and FOIL this. So square root of x times square root of y, that's, I have 2 under the radical, that's how I got y. And then I'm going to do my outer. So I multiply those, and I got 2 square root of 3. And I'll do my inner. So then I got 3y square root. And then I'll do my last terms. I have negative 2, 3 times 3. I have the set of 3's that come out. That's how I got negative 2 times 3. That's how I got minus 6. I'm going to combine my like terms. These two middle terms are my like terms. That's how I got square root of 3y. And that's how I got that solution. Number 28, I'm going to go ahead and simplify this. I'm going to distribute my negative 4 to everything inside of the parentheses. So 16 to the negative 4, that negative means change locations. That's how I got 1 over 16 to the 4th. Then I have negative 4 times 1/4, so that gives me negative 1. That's how I got 1 over x. And then 3/4 times negative 4, I notice those 4's cancel out, and I'm left with y to the negative 3rd, so that goes in the denominator. That's how I got that solution. Problem 30, to simplify, I notice right away it says negative 10. So that means change location. So that negative 10 goes down in the denominator. So x to the 10th times x to the 5th is x to the 15th. Now I'm going to distribute that 2/5 to my numerator and denominator. 1 to the 2/5 is 1. So I end up with 1, my numerator. My denominator, I have 15 times 2/5. And I notice 15 and 5 reduce by 5, so I get 3 and 1. So 3 times 2 is 6. That's how I got x to the 6th. In problem 31, they tell us already how to figure out the radius, so we don't have to change that equation. So they give us the radius, it's 169 pi. They give us the area, it's 169 pi. So I'm going to plug that into 169 pi. And I notice right away that pi and pi cancel each other out. So I get the square root of 169. So I get plus or minus 13. But circle cannot have a negative measurement. So the radius has to be positive 13.